So, have you ever tried to use a powerful large language model for some serious professional work, only to kind of hit a brick wall? Yeah, you're not alone. The big question for everyone right now is, how do we make these incredible but sometimes flaky models reliable enough for real enterprise use? Well, today we're going to break down the architecture that's doing just that. It's called Retrieval-Augmented Generation, or as you'll hear everyone call it, RAG.
This quote from Pinecoon's documentation just nails the core problem perfectly. It's not just that large language models get things wrong sometimes, it's that they are confidently wrong. This whole thing is what we call hallucination, and it's the single biggest reason we can't just plug these things into mission-critical systems. They can sound so convincing while literally just making stuff up.
So why does this even happen? Well, it boils down to a few really basic limits. First, these models have a knowledge cutoff. Their understanding of the world is literally frozen in time. Second, they have no idea about your company's specific niche, and this is the big one, they can't see your private data. They just can't. And you have to remember, at their heart, they're just incredibly fancy prediction engines. They're built to guess the most likely next word, which is fantastic for writing a poem, but not so great when you need cold, hard facts. And all of this, it leads to those really frustrating and honestly potentially dangerous hallucinations.
Okay, so how in the world do we fix this? Well, think of it this way. If a standard LLM is taking a closed book exam, relying only on what it's managed to memorize, then the solution is to give it an open book. And that, right there, is the entire idea behind RAG. We're not trying to make the model memorize more stuff, we're giving it a library it can look things up in real time.
So officially, what is RAG? It's a technique that grounds an LLM in an external knowledge base. Here's the key. Before the model even tries to answer your question, it first goes and fetches relevant, factual information from a source you trust, say your company's internal wiki. It then takes that information, that context, and uses that to build its answer. Basically, we're forcing the AI to show its work using your data, not just its own fuzzy memory.
And this comparison just makes it crystal clear. A standard LLM is taking a closed book test. A RAG-powered LLM, it's got the textbook wide open. And what that really means for you is that its knowledge can be updated instantly, just add a new document. Its answers are grounded in facts. And, this is absolutely crucial, it can cite its sources. You can actually check its work. This builds trust. And in any serious business setting, trust is everything. All right, so we get the what and the why. Now it's time to get into the fun part, the how. We're going to walk through the whole architecture, step by step, and see how this thing actually works under the hood.
Okay, I know this diagram looks a little complicated, but don't worry. Just think of it as our roadmap for the next couple of minutes. It shows the entire journey, from a user asking a question all the way over on the left to getting that final trustworthy answer on the right. We're going to break down exactly what's happening in that big middle section.
The whole thing breaks down pretty cleanly into two main phases. First, there's indexing. This is all the prep work, the heavy lifting you do offline to get your knowledge base ready. Think of it like organizing your library before it opens. And then there's retrieval and generation. That's the super fast process that happens in real time, every single time a user asks a question.
So let's start with that offline prep work, the indexing phase. The very first thing you have to do is called document chunking. You can't just throw a 100-page PDF at the system and hope for the best. We need to break our documents down into smaller, more focused pieces. And getting the size of these chunks right is super important. If they're too big, you might confuse the model with a bunch of irrelevant info. Too small, and you might lose the context. The goal is to create these perfect, bite-sized, meaningful pieces of information.
Okay, once we have all our text chunks, we need to translate them into a language that a computer can actually work with. And this is where it gets really cool. We use something called an embedding model. Just think of it like this. It gives every single concept a unique coordinate on a giant map of meaning. The model turns each chunk of text into a long list of numbers. That's the vector. And that vector represents its exact location on this meaning map. Chunks that talk about similar things will end up with coordinates that are really close to each other.
And where do we store all of these millions of coordinates? Well, we put them in a special kind of database called a vector database. You can think of this as the super high-tech GPS-enabled card catalog for our AI's library. It's built to do one thing incredibly well: store all those numbers and, when asked, search through them at lightning speed to find the closest points on our map. This is the core of our open book.
Now we get to the real-time part. A user asks a question. The system takes that question, and it uses the exact same embedding model to figure out its coordinates on that map of meaning. Then it asks the vector database, hey,
What are the closest, most similar chunks of text to this location? The database runs what's called a similarity search and instantly finds the text chunks whose coordinates are mathematically closest. And boom, those are the most relevant pages from our open book for that specific question. So this diagram brings the whole user journey together. The user asks a question. First, the system retrieves the most relevant facts from that knowledge base we built. Second, it augments the original question with this new factual context. And finally, the large language model generates an answer based only on those specific facts we just handed it. Retrieve, augment, generate. That's RAG.
Okay, this brings us to a really important question. It's probably the #1 question people have when they start building these systems. How does RAG stack up against fine-tuning? They both seem like ways to add new knowledge to a model, so when do you use one versus the other?
Let's just ask the question directly. Say you have a bunch of new product manuals you need your AI to know inside and out. Why go through this whole RAG setup instead of just retraining or fine-tuning the model on those new documents? It's a totally fair question, and the answer really gets to the core of what these two techniques are actually designed to do. And this table just lays it all out. The biggest difference, the one thing to remember, is the goal. You use RAG to inject factual, up-to-the-minute knowledge. You use fine-tuning to teach the model a new skill or style, like how to answer in perfect JSON format or how to adopt the persona of a pirate. The analogies at the bottom are perfect. RAG is like giving the model a library card so it can look things up. Fine-tuning is like sending the model back to school to fundamentally change how it behaves. They are two different tools for two very different jobs.
So RAG is clearly the right tool for injecting knowledge, but that does not mean it's some perfect, magical solution. It's really important to be realistic and have a hype-free view of this. So let's do a quick reality check on where it's at today, and then we'll take a little peek into the exciting future of where this is all going.
RAG is a massive help with hallucinations, but it doesn't totally eliminate them. It's possible for the model to still misinterpret the context it's given. You can also run into something called RAG poisoning, which is where the system pulls up a document that's factually correct, but totally misleading for the specific question you asked. And then there's this weird problem called lost in the middle. If you give the model too many documents as context, it can sometimes get overwhelmed and actually miss the key piece of information that's buried somewhere in the middle.
But the good news is the AI community is moving at an incredible pace to solve these exact problems. We're now in the era of what people are calling advanced RAG. There are techniques like HIDE, which is super clever. It asks the AI to first imagine what a perfect answer would look like, and then it searches for real documents that match that hypothetical answer. You've also got re-ranking, which adds a second, smarter model to sort through the first batch of results and put the absolute best one at the top. And then there's graph RAG, which is on a whole other level. Instead of just looking at which words are similar in a text, graph RAG builds and uses a knowledge graph, like the one you see here, to actually understand the relationships between different concepts. So for example, it doesn't just know that documents mention a CEO in a company, it understands that a CEO runs a company. This allows it to answer way more complex questions by following those connections, adding a really powerful new layer of understanding. So there you have it. RAG is a massive leap forward. It takes our incredibly powerful language models and turns them from creative generalists into reliable experts that have a perfect memory of your data. It grounds them in a source of truth. But that leaves us with one last really fascinating question to think about. If RAG is the technology that grounds AI in facts, what's the next great leap that will ground it in true, multi-step reasoning? That's the next frontier.